So last time we discussed Apache, how a website is hosted. We did a default website hosting. Then we saw if we have multiple IP addresses and we want to host different websites with different IP addresses on the same machine, we did that. We saw that if we have one IP address and one machine and we want to host different multiple websites, how we will host that. We installed MySQL database, we created a database, and we gave some permission to the database so that our application can connect to the database. And it was a scenario like if we are running a WordPress or any PHP or HTML website on our machine. Today, what we will do is one hosting software is Apache. In Microsoft, it is Internet Information Server or IIS. Then in Linux, again, after Apache, there is a very efficient tool that is called NGINX. So first, we will install NGINX, which is very pretty simple. Yum install nginx -y. And before installing nginx, we will install EPEL release. And I told you what that is. It's for the extra packages for RHEL. What we did was, just taking too much time, we installed Apache and we created the database. So what I did was I created everything through command line. Now I want to show you one more thing to configure your databases or create database. That's the one last topic for Apache. Yum install -y php myadmin. So php myadmin installed. I will open the configuration file. And what I will do is I will just modify one setting. This is my client IP address 192.168.16.1. This is me. And I guess that's it. Service HTTPD restart. And let's go to the browser. And I will try 192.168 or 16.139/php myadmin. So this is my PHP myadmin web interface. I will provide the password of database root, and the password was root123. This was the password we set up while configuring our database. So like if I press go, okay, as I have just rebooted the machine, so I will need to start service MariaDB start. I will switch to the browser again and let's try to log in. So this is our database server. I have created database example, and on that example, I have created user. Privileges. I think I created a user. Test. Where's that user? Anyway, if we want to create a user from here, we can create a new user.
I don't remember you adding a test user when you created a database.
No, I remember I did that because we did the test configuration. As you can see, MySQL -u root -p root 123, and you see, okay, last command was revoke all. So I did that, grant all on example.com to test @localhost identifier by password ABC. And after that, we were able to connect to our to database to our application, if you remember, right?
Yes.
Okay, so but I think in the end we have deleted and revoked the permission. So I did that again, and now let's do a refresh. And the test user is here. So actually what PHP myadmin is doing, it is pulling the configuration from the database and displaying it in a sort of, it's sort of a website. PHP myadmin is sort of a website. It pulls everything and displays it graphically. And whatever you are doing, like if I am saying, add another user. So let's say username is Bob. And I say any host, anyone can connect, or I can say localhost. I can give IP, let's say local. Password will be ABC123, ABC123. And I told you, you can give rights like select, insert, update. I am saying that, okay, everything. If I press say go, you can see, okay, I can zoom it a bit. Create user Bob at the rate localhost identified by the password, grant all privileges on this Bob, and so many options which we have selected graphically. It has converted into a command, and that command it has run on the database. So this is actually a website. Whatever you do, it creates a syntax for you and it applies it to the database. So that's all about phpMyAdmin. We manage the database through phpMyAdmin. Got it? So now let's move back to NGINX. I can say quit. So now I have two users, Bob and example. So I was saying it was as simple as that. You install NGINX and you're good to go. User share. No, etc NGINX, and we have NGINX available. So let's open nginx.conf and let's see where is the root directory. Let's user share nginx HTML. I'll go to the root directory, the default root directory, and there is already index.html placed there. I will move index.html to index.html. That back. Okay. Okay, it's already there because I did it, and I opened index.html and I wrote our nginx website is running here. So I entered this test while testing. And if I go to the browser, let's check one more thing first. Netstat minus nf more. Database is running, and probably our Apache is also running or not running. On port 80 it's listing, so Apache is also running. And vi etc nginx.conf, and we said the port should be 8080 for nginx. Yes, it's so I can start it safely. Service nginx start. So nginx is started. And if I go to the browser again, and if I say port number is :8080, so our nginx website is running here. So it is very pretty simple scenario, but there is one problem here, because natively, like Apache, nginx also do not support PHP. So we have to configure nginx to support PHP. So how we do that? First, let me do a touch page for index.php page. And okay, or what I can do is rm-r index.php, and I will say cp or www. I had xyz.com and index now abc.com, index.php page already there. So I have copied it here, index.php, and the content of index.php is okay. It's the same code which we are running in Apache. So let's go to the browser again.
Jishan, it exposes the password like that?
Yes, it's on the website or in the configuration?
No, in the machine.
Yes,
on the terminal.
On the terminal, yes, it exposes the password like that.
Wow, okay.
I mean, you are the administrator, you have written this code, you know the password.
Okay, yes, but
yeah, it exposes like that. So let's say I do index.php here now, and you see it is opening the PHP page, like it has downloaded it as a file, because it do not know how to process this code. You see, it has downloaded this file to me, that this is the file. Actually, this is not the file. This is a code, PHP code, and you need to process it. So let's go. Okay, come on, I cannot. You see the code, or I need to share it? I think no, you cannot.
You have to share it. I cannot.
Yes, actually, I have opened a website and it has shown me this file, that this is a PHP code, because right now it cannot process PHP pages. So let's go to the terminal and see how PHP support is enabled in the document is available. I will do is I will pretty much copy paste everything from there, and you can. And I will explain how I'm doing it. By the way, you have not used the Apache document, I believe.
Not me.
No, I guess nobody. So I'm going to NGINX. Let's say I have created a copy. NGINX.conf, NGINX.bat. No, I have not created it. So, oh no, I have created it. No. So first thing, before you start configuring any file or you are changing anything, you should make copy of it. So I have made a copy of the file so that if anything goes wrong, I am able to go back. So whenever you're doing anything, you should have a rollback plan in your mind, that if I do this, so if anything goes wrong, what will be the rollback procedure? So here I am just downloading some stuff, some repos, and it is pretty much standard. Nothing to do. Okay, I think it's already done. And let's see. So I'm downloading a few more packages. Okay, I have PHP 7.0, 7.1, 7.3, 4, 5, 6, 7, 8 available, and I will prefer 7.4 because the syntax I am using is that's working there. I have tested. So now what I can do is I can install, like when we were installing Apache, and we install Apache with PHP and PHP with PHP-MySQL. So for NGINX, the command is yum install PHP, PHP-MySQL, and PHP FPM. We will use fast processing manager. Just ignore it. I will share the document. It is pretty much copy and paste. And the important thing is how we do the configuration. So let's say download it. And I have installed PHP version 7.4. So we are enabling PHP support in NGINX. Before installing this, we had some couple of RPMs and we have enabled some repositories. We have done the background work. So that everything is covered in the document, and I will share the document in the end.
Zishan, which document you were talking about that we didn't see?
Just like I have created a document for you guys to install Apache.
Yes.
So I have created one document for NGINX also.
NGINX was with Apache.
Yeah, it was like.
It was all the way in the bottom. I saw that. You created another document?
No, it's the same document, I guess. But with further few steps, maybe I will see what I shared yesterday. I think everything is not there in that document. If it's there, then fine. I'm using the same document. So I'll check that again. So this is a file which we need to configure. It's all there in the. And I will search the word listen. Oh, yes. And I told you, if you want to search something, you put a / and the word. So this is the configuration of listen. It is saying I am listening on this IP address. I am saying no, don't listen to IP address. Listen to socket. And change the owner. I will search for owner now. I will press escape / again. owner, and the ownership is semicolon means comment out, and I am removing semicolon, so it is now active configuration. And I will say the user is NGINX, and the group is also NGINX. And listen mode, just leave it, and we're gonna quit this file, write and quit. And what we will do is we will start the process PHP FPM. So our PHP FPM is done. What I will do is now I will tell my NGINX to process the PHP pages. So what we will do is we will open the NGINX default configuration file. We have already taken the copy of it. We have created the backup, so we can easily change this file. So the user is NGINX and the worker processes is auto. What worker processes is, the beauty of NGINX is it uses multi-cores. If the machine has 4 core available, if you have 8 core available, if you have 10 cores available, it will start using all the cores automatically, or you can fix it. Okay, do not use more than 4 cores. So worker processes is the assignment of cores. So Apache is a single-threaded application which uses the cores, but this NGINX works simultaneously on each and every core. So the processing is so efficient. With one process, we can define how many connections you want to create with one, let's say, worker process. So on one process, you can have 1,000 users or 1,000 connections. On a second process, like on a second core, you can have another 1,000. On a third core, you can have another 1,000. So that's how NGINX behaves so beautifully, that each process is assigned with a core, and it starts working independently. And we can, if there is too much load, we can tune the parameters, like we can reduce the connection to 512, and we can increase the cores to optimize the performance of a website. So these are very important two things: worker processes and worker connections. You have to create a balance between your these two things. And this is only required when there is abnormal load on your website. Then we have this is our HTTP block. The log format, the access log is going in var log NGINX access log, and there is some default parameter, but our server is listening on port 8080. And there are these error pages, 500, 502. I mean, these are the error codes. The most common we will see is 402 and 404 not found. So these are the error codes which are sent by the server, and our browsers process it. If it is 404 error coming in the response, it means the web page is not there. If it is 502, maybe the server is up, but it is not able to process the code. Maybe there is some bug, or there is some error in the code, and the server cannot compile it. There is a 300 error that this URL is, moved to some other URL. So next time you can, this is 404. And so these are the error pages which will be handled. But the most important thing is we want the server to process our PHP pages. So what I'm gonna do is, again, this is a pretty standard configuration. Insert. I have added this block here. This is to process your PHP pages through this PHP FPM package we just installed. Let's say I can save this file and I do NGINX -t. It is saying the syntax is okay and the configuration is good, so we can restart it. Service NGINX restart. And let's go to the browser again.
Jishan, before you go, why did we mention listen twice, even though it's different?
Wait a minute. Which listen?
Can you go back to terminal? The
Yes.
code you mentioned listen twice.
Yeah, this?
I can see your screen.
Okay, so sorry. This.
Yes. Why did we mention twice? What's the difference?
It is IPv4, it is IPv6.
Ah, okay. Got it.
But I have not assigned any IPv6 version, so I am saying listen 8080. it means on a local host port 8080. And if I am typing in this syntax, it is listening on IPv6 stack on localhost.
Okay.
But we can fix the IP address here for IPv6 and IPv4 also.
To make it more static?
Yes, to make, or maybe there are other things also. I mean, we discussed that if we want to run a typical website on a typical IP address on the same server, I have another IP address, and I want to run another another website on that IP address. So it depends on scenarios. So we did discuss everything in the previous class. So
Okay,
let's
I'll
go to the browser, and where's my browser? Okay, no, that's not my browser. Okay, I think. Yeah. So let's try to do index.php now. So connected successfully. We know on port 8080, we have NGINX running, and on that NGINX default location, I have placed index.php, and it is connecting to the database successfully, and it is now processing the PHP code. Right? This is what I can show you is, let's say, if
in progress
service MARIA MariaDB stop. I have now stopped the database. And let's go to the browser again. If I hit the refresh button, connection failed. So the MySQL is not running, the connection is failed. Let's say if I do start this, and I say MySQL -u root -p. So what I'm going to do is I am revoking the permissions, and let's see what error. The error is change to access denied for user for this database example. So that's how the database permissions are revoked and assigned. And PHP is also already processing our. Let's grant it again, and it will be done. So that's how we host a website on an Apache server. We host a website on NGINX server. But if you want to install, if you want to host multiple websites on a single NGINX server, just like Apache, we can do it. We can do it very easily. We have, where are we? Okay. We can go in conf.d, and we can create our websites just like Apache. We did httpd.conf. Here, we can do the same thing. We can do touch, 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 my website.conf. So again, like Apache, we can host multiple websites on a single machine. We put the configuration of a virtual host here, and just let's see my website.conf. We will define the server here, server block, and we will define the directory here, just like listen on port 80. The server name should be like www.mywebsite.com space the proxy of it, alias my website.com, and we will define the default directory, the document root, everything, and we can copy it from the main file vi nginx.conf. We can copy this block and paste it there. So that's how we do the multiple website hosting in NGINX. If you want me to do it, I can do it for you, but it's the same thing we did for Apache. Otherwise, I will explain you how a better way why NGINX is used, and mostly it is used as a web server for a default single website, or it is used as a load balancer or as a reverse proxy. That is more interesting configuration. If you want, I can go there, or I can host a website here and show you in detail how 2-3 websites are hosted. I mean, it's the same thing we did with Apache. So what do you think?
No, I would prefer to do with the load balancer and all.
Yes,
that way
load balancer.
we'll have two different scenarios to learn.
Yes. So let's say
that's my opinion. You can ask everybody else.
I'm fine with that. So whatever.
So okay, we can what I can do is I have another machine already started. 192.168.16.134, I guess. Yes, root 123. And I can share the screen. This one. So this is altogether new machine. And you know the IP address of my old machine on which Apache is running, NGINX is running, MySQL is running. That's a machine with the IP 16.139. 139. So this is 134. Okay. So this is a different machine. And I can show you next stat -NA, type more. So no Apache or NGINX is running. Let's say, I guess I have installed NGINX here. Yes, I have NGINX here. So let's go to NGINX. I have made, doesn't matter if I had made a copy or not, because I know we will make a copy. And this is a sample.conf. What I was doing it. Okay, I know what I was doing here. So leave sample.conf. We will discuss it later. So going back to NGINX as a load balancer. So everybody knows what's a load balancer. Or should I explain? Hello? Okay, let's go on.
I have a brief.
Let's stop everything. Let's stop everything. I'm going on the board.
Okay.
So what's the typical scenario? We are learning that we have a web server. Our website xyz.com is hosted here. The problem is that, and we have our database already running here. So this is our website code index page, index.php. So index.php, our code is running on this machine. The database is here. But the problem with this scenario is, if we have a lot of customers, and what we can do, we can manage the load by increasing the resources. We can say you can assign 64 cores, 64 CPUs. You can say 128 gigs of RAM. Okay, if this is not enough, you will give 256 gigs of RAM. You can give 128 core, but there is always a physical limit. You cannot go above that. That cannot be more than your physical system resources. So this is called a scale-up architecture. And we should not go with a scale-up architecture. We should always go with a scale-out architecture. So what's a scale-out architecture? You should have another server. Same configuration, xyz.com. You should have the same index.php page. But the problem is the database. If you have the same, either this NGINX will connect to this database, and this code will also connect to this database. You cannot have separate databases, otherwise the backend state will change and your data will become inconsistent. So when we go with the load balancer, we use a different approach.
So this is on a different machine?
Yes, these two are different machines.
And one machine is handling the database.
Yes, but that's not a good approach. If we are going with the load balancer, what we should do is we should separate the database. And every other server should host a website, and this should be the database. So they all connect to the same database. They can all save, copy, insert, delete the tables, delete everything from the same database, so that the database should be the same. And mostly the content is fixed, but this is dynamic. But again, it depends. Maybe you are running a website on which you are hiring for some post and you're receiving the documents, the CVs. Okay, the CVs and the documents, they don't go in the databases. They normally go onto a file server. So let's say if some student is applying or you are applying for a job, you are uploading your CV. Maybe the load balancer send you to this server. You can create a link that I have CV uploaded in this folder. Okay, you log out, you log in again. The load balancer sends you on this server. You will find for this document, but this document is available only on this server. So now again, that's not good. So then again, there is an option. There can be multiple options. I will discuss one of them. We can have an NFS server. What is an NFS server? We can do it in the class. You can create a directory here, and you can share that directory on every machine, the same directory. So whatever is written here is actually written here. Can you see the screen?
Yes.
Okay, and this directory is already shared here. So whatever is here is actually visible to all of them. So if we are going for the load balancing, we have to plan it carefully. So if this server has any issues, so these two servers can share the load. And if we have database available, we can make a cluster of a database. So this will serve as master, and this can serve as slave. So if your master goes down, at least you can work with the slave, and you can make slave your master till you restore your master database. There may be many different configurations depending on your database type. Like Oracle is giving different configurations. You can go with the active. These both database can act as master nodes. In MySQL, you can only go with master and slave. You can go master, but with XJ proxy enabled. But that varies upon your database. The MS SQL Microsoft product, they go with active slave always. So if primary goes down, it automatically switch to slave, make it master automatically, and the load starts serving from there. And when your primary comes back, it automatically switches back. I mean, these are all the policies you can configure. So let's say if we are going with xyz.com website and we have, let's say, 100 servers. So the problem is that if you change the code here, you have to change it to all those 100 servers. Even if it is a minor change. If it is a minor upgrade, you have to upgrade your all front-end servers so that the user, whether comes on one machine or the 100th machine, it should have the same code available. Any confusion till here?
No, I do have one question.
Yes.
So the database master and the database slave, they're the exact copy, right?
They are the exact copy. Yes. They are mirrored actually.
Okay.
But let's say nothing is wrong with database master, but your link is broken. Of course, it's another server. There may be some network glitch. Maybe your the database server goes down and whatever. So the slave state will be old state. But whenever it comes back online, it will sync with the master and it will maintain the state again. So it will always follow the master, right?
Yeah, got it. And you said if we make any changes to the first index PHP, you have to do that to every other server. And you're doing this through NFS, right?
No. You can do it through NFS, but NFS is mostly it's for file sharing. That if somebody, it's a application, it's a hiring application, and you are uploading the documents. So if you are uploading the documents on this server, on this machine, then those documents will not be available on this machine, right?
Right.
But next time you log in to edit some document, you can come on this server because it depends on load balancer on which server it will forward the traffic. And you want to view your resume or CV, that will not be available here. So for that, we create a shared directory, which is shared among all these servers, and we do it through NFS. There is a separate server for NFS, Maybe this can be a hardware device, that can be a remote Google Space storage, but that will be mounted here. So all the applications or all the CVs or all the files, images, pictures, those will be coming on that shared drive, and that shared drive is actually mounted on each and every server. So their data is available on every machine, whether you come to this machine, or this machine. So this is one thing. You are sharing one mount point, and it should be same across all the web servers. Your front ends, these are called the front ends, and your data is shared through NFS. So this is a separate sharing server. The problem is your code is mostly static. Let's say the code is not changing, thus the data is changing, but you have the new release available, and you are doing any modification in this index.php website. So if this same version is not same across the board, so if some user is hitting this backend web server, he will have different code, and if someone else is hitting this server, you will have different code. So the code should be the same on all the servers. So the field should be the same, that I am browsing the same website. Is there any confusion in this?
So when they update the code in
They do it
index.php,
on
will
all
that
100 servers? Yes. You might be thinking it is too tedious.
It's not about tedious, but I'm just wondering, is it why there are different concepts? Is it the same as database master mirror to slave, or is it a different?
Yes, no, it is like you have to do it through GitHub. You can pull the code on all the servers, or you can use rsync. And why do you think Ansible came into the market? This problem is solved by Ansible.
With all the
Ansible,
that...
yes, you will run the playbook that, okay, I have this master
That makes so
server.
much sense.
You will just pull the code on your master server from the GitHub or GitLab, and you can write your playbook that the Ansible will go on each and every machine, and it will download the latest code to all the servers, and those 100 servers will be upgraded like that. And this is this can be achieved through rsync. This can be achieved through writing scripts, but Ansible is the most efficient way, because everybody cannot write the scripts. So there comes Ansible. So when your servers start growing, so it started making mess. And plus, if you are the developer, you're uploading the code to GitHub, but it is very unlikely that you are also the administrator. Maybe you are sitting in California, maybe the servers are running in New York, and the administrator is different guy, the developer is a different guy. So if you are uploading something in the code may be, let's say the size of the code can be 100 MB or maybe 2 GB. So which file you have updated, you don't know. So either you have to check the complete code, what's changed. So it has so many problems when we do it through scripts or through other scenarios. That problem is solved by CI/CD and Git, that the pipelines do the work and everything is automated. Before, it was a manual procedure before this DevOps. So it starts making sense, right?
Yep.
Yeah, I didn't think about Ansible, but now with using Ansible, this makes more sense.
Yes, you can automate a lot of stuff through Ansible. We will discuss Ansible, but let's say first we can see how this load balancer stuff works. It is pretty simple. I mean, you will be amazed how simple the configuration is.
One other question I have. Oh, sorry, go ahead.
No, sorry. Okay. I love questions. Speak.
Somebody else were asking questions, so I'm waiting.
No, I think it's you only, or maybe Karan.
No, I didn't hear anybody.
Okay, all right. So my question is with this NFS. So NFS is only document storage. So what's the difference between NFS and database master here?
Database is a structured stuff.
Okay, so say suppose if I go into dice.com or monster.com, what are the information that I provide, my first name, last name, and everything will get stored in database master.
Yes,
but
exactly.
The resume that I update or any kind of documentation that I update, that gets stored in NFS.
It's stored in the NFS, and only the link to the file is stored in the database.
Okay.
That this file is placed there, because the databases are very sensitive and they're very tricky to manage. If you are putting all the files inside a database, So the database side starts growing, and then it will be very difficult to back up that database, to move that database, and to manage that database. So the NFS server is very easy. You are just putting the file there, you can create a copy easily, and so on. So NFS is for files, database is for structures, just username, passwords, links. And the one other thing is database is normally installed on a very high performance disk, maybe SSDs, maybe SSDs with RAID 10, because we need performance through the database. But for NFS, it is normally very slow storage, because whenever the CV is uploaded, you don't need to, maybe, I don't know, you will not go to the your CV again and again for editing. And even if you are editing, you will open the file and you will do the update, you will do so many stuff, and you will save it back when you are done. So there are very minimum input-output operations on your storage. So NFS is a cheap storage, and the resume size can be 4 MB, 3 MB, and there can be thousands and thousands of resumes. So it is better you place them on NFS. I mean, this is how we optimize the solutions.
So a better example for NFS, can we say Dropbox?
Yes, correct. Dropbox, Google Drive.
Okay.
Any object storage, any file storage, and there are hardware solutions available. Before it was NFS, you have to set it up, but now everything is available on cloud. You don't care. You can provide a cloud link here. Okay, upload everything to the cloud. And when I retrieving, but the connection should be good so that your user behavior, user experiences, you're not hitting the user experience that you are downloading a file, and if the connection to the cloud is broken, so the file is not available. So it depends on you. Either you are hosting the complete solution on the cloud, or you are doing mix and match. Your servers in your data center, storage in the cloud, and you can do everything in your data center. I mean, we are discussing also the air-gapped environments. There are environments where you cannot use the cloud, you cannot connect to the cloud. So you have everything locally available. So that's how it is done. So let's go to the command line again. And this is what, let's first check. It's 139. No, I don't want to use it. So I will use this one. Okay. I have written a code. I will copy paste it first, and then I can explain it to you. So I can touch xyz.conf, and the text size is okay for you guys?
Yeah, I'm good.
Okay. So leave this first block. I am starting with the second block that, okay, listen on port 80. And the server name is xyz.com. And I'm saying it if someone is typing www.xyz.com, it's okay, fine. And what I can do is I will just do proxy pass. Whatever comes to this website, proxy pass to XYZ. And I have defined my XYZ block here. And in that, I am saying that my backend server is 139. Backend server can be 140. Backend server can be 141 or whatever you want. Okay, so you can do IP hash. You can define the IP hash that load balancing should be done through the client IP. If the client is coming and the IP is same, you will always send the request to, let's say, 139. If the first hit is on 139, it will always come on 139. If you don't give IP hash, it will do round robin. First request to first server, second request to second server, third request to third server. So these are all load balancing mechanism. You can go with minimum load. You can go with the IP hash. You can go with the round robin. I mean, these all depend on your scenarios. I prefer IP hash. That's the most efficient in terms of user experience. I don't know how the developer has managed or handled the sessions. If he is maintaining sessions in a file, so it is better that the user always come on the same machine. If it is managing the sessions in database, maybe it doesn't matter. You can go with the round robin. So it depends, but IP hash is the safest way, as per my experience.
So in both the methods, you have to define the servers.
You have to define the backend. Of course, you have to tell which upstream you want to connect. I should commit 141 because it's right now not available. Or if you want, I can make a clone of 139 and when we can use 141. It all depends. But for, right now, I am going with single IP.
Yeah, that's fine. That's fine. I just want to know whether do we have to define or
yes, you
does it-
have to define either it's a
Okay.
physical load balancer or a virtual load balancer. You have to define your upstream, because how otherwise how NGINX will know where the upstream is. You can
Yeah.
define the IP address, you can define the host names, but those host names then should be resolvable by your DNS server.
Okay, got it.
So what is this set header real IP remote address? And there should be a X forwarded for. I will discuss the connection timeout should be 90 seconds. These are buffer size should be 128K. We don't need to mostly change it. It's pretty standard. So let's say now our xyz.com is hosted on 139. Let's first check if this configuration is okay. And the next -T looks good. Service NGINX restart. Okay, either restart or reload. Both will, if it is already running, you can reload the configuration by using the reload command. Now the point is we have not defined any index space here. Do we agree?
Yes, we did not
Yes.
define.
We just proxied the request. So I will go to the other screen and I will start my Apache. I think I had stopped it. So service HTTPD stop. Oh, sorry, start. First, I check the status. It starts, so START start. It started, and we have etc HTTPD cd sites enabled. Okay. I guess I have again removed the link. Some more abc.com. It's there. So site www then abc.com. So we have index.php available. Okay, fine. I'm gonna change something in the here because I want to do is okay, leave the configuration file as it is. It doesn't matter what file you what name you give to the file. So what I'm gonna do is I will switch it to abc.com because xyz.com is no more there. So I will do percentage source xyz, change it to abc, and we are good. So upstream is abc and server name is abc.com, abc.com, abc. Yeah, we are good. So now I will reload the configuration. So you know what I did, right? Because
Yes.
we have abc running. So now I go to my notepad.
We can see the notepad.
Yes, I was sharing. I will go open and let's say hosts, and I will define abc.com to 134.
Just quick question. When you define in the terminal, you put abc.com to 139 though, the backend.
Wait a minute. I think, yeah. Let's go back to notepad. Yeah, here. What you were saying, abc.com, this is our website, which is running on 134, right?
It is running on 134, but the backend you gave 139, right?
No.
Can you go back to the terminal?
The website, let me explain, then I'll go back to the terminal.
Okay. Thank you.
134 is our NGINX load balancer. Agreed?
Yes.
And the website is running on 139. It was installed on our original server, if you remember, or else I can show you.
No. I got the point.
You got
now.
it?
So 134 is only NGINX load balancer.
Yes, it is. It will send the request to NGINX, and NGINX will pull the data from the 139 and serve us to 134. So that's how the load balancer works. So the load balancer works on top of all the servers. Got it?
Yep, got it.
Okay, so let's switch back to the console. First, I will go to 139 to show you. So this is our abc.com. Okay. If I go to cd log and more requests.log, you can see there is always IP address 192.168.16.1, right? This is the IP address of my machine. Now, if I can do tail -f requests.log, and if I go to the browser and type XYZ, oh sorry, ABC, I guess in the wrong website. I was working with, no, I'm in the right, I am working with the ABC.
abc.com. Yeah.
abc.com. Okay, I know what I did wrong here. So let's go to this machine and service. Yes, it's on. So going back to, I did the refresh, and you can see, you cannot see. I have to share the complete screen. Share the. Okay, just leave it. I can share this screen again. Okay, I am hitting the refresh. You trust me, I am hitting refresh again and again. Okay. So if you see, before the IP address was 192.168.16.1, which is my IP address. Now the IP address is of proxy.
The load balancer.
Yes, the load balancer. So what should we do now? This is a problem. So on my website, on my machine, we are having the IP address of the load balancer or the proxy, and we do not know who is hitting our web server. Of course, the logs are available with the load balancer, but as a system administrator, you should know who is hitting the website. Which IP address? Maybe you need to troubleshoot something. Maybe you need a customer to troubleshoot. He can tell you the IP address that I am coming from this IP address, and I am having this issue. So we do is vi etc httpd conf.d and abc. Okay, now I did it in sites available abc.com. So there comes our log. We were using the default log format, and now I will switch to my custom log format. I am uncommenting this. I am uncommenting this, and I am commenting out the original requests.log. I can call it request.request.log, or I can call it access log. I mean, this is the name defined. So what I am doing here is I am just telling the log format that grab some extra features, like grab the field X forwarded for. So I have changed the log format. I have taken, just remember this word X forwarded for. And there are some other settings which I have done. So let's save this file and just align it a bit. X insert space log format. Yeah. So what I will do is service httpd restart. So print working directory ls. Now if I do tail -f access log. So now I'm gonna hit the website again, and you can see the log entry. So I have refreshed the website. You see the proxy is this IP. The client is this IP. I have manually entered the word proxy. I mean, you can type anything here. I am saying client, or you can say user, whatever you want. And I have taken further parameter as it is. So now we are for sure, you can see that the request is coming through the proxy, the load balancer, or the reverse proxy. That's called also a reverse proxy actually. So that's how we do NGINX as a reverse proxy. What you can do is you can run a website. You can run xyz.com on NGINX, and on the same time you can use NGINX as reverse proxy, but by just defining the configuration there. That for this website, this will be a local server. For this website, I will forward request to another server, and I will pull the data from there and I will present it to you. So you can have one front end and you can have many backends, just like that. And I prefer to modify the log format like this so that I have the client IP address available.
Makes sense.
Makes sense, no? So you should know who is hitting you. So at least you can tell if you see a suspicious traffic, at least you can tell the network guy, okay, look, I mean, the network guy is in control of every network traffic. So you can tell him, okay, this guy is making some suspicious request, kindly block it on the firewall level.
Okay, got it.
So that's how amazing and powerful NGINX is as a load balancer. You can decrypt you can offload SSL traffic. You can do so much on NGINX. And I'm talking about the free version. There is a purchased version also. So you can buy the subscription and it has then more features available. It can do the application load balancing and so many stuff it can do. I mean, but we are good with as a reverse proxy, we are good with the free version. So that's how we do the load balancing. I'm switching back to NGINX. This is our NGINX. So now I can do, the name is xyz.conf, but this is just the file name. So the configuration is this. So I will start adding IP addresses here. And this is that X forwarded for field. So in the header, it will add another header X forwarded for, in which it will take the client's IP and forward it to the backend server. So this is the X forwarded for field, which we are grabbing in our log file on the Apache server.